Right now, inside your body, something is happening that most people think is a malfunction. Your temperature is rising, your skin is burning, you're shivering even though you're already too hot. And if you check a thermometer, the number is climbing past what you've been told is normal. But here's what almost nobody tells you. Your body didn't break. It made a decision. The fever is not the illness attacking you. The fever is you attacking back. Put simply, your immune system just turned up the thermostat on purpose. Under normal conditions, your body holds its temperature at around 37 degrees Celsius, not by accident, by constant active regulation. The part of your brain running this is the hypothalamus. Think of it as a thermostat. It reads your core temperature every few seconds and makes tiny adjustments to keep it exactly where it wants. Look at this. When a pathogen enters your body, a bacterium, a virus, your immune cells detect it immediately and release chemical signals called pyrogens. These travel through your bloodstream until they reach the hypothalamus. And when they arrive, something precise happens. The hypothalamus raises its target temperature. The set point moves from 37 to 38.5, maybe 39, maybe 40 degrees. The thermostat just moved. And now, relative to the new target, your current body temperature is too cold. Your body isn't overheating by accident. Here's the key point. It was told to get hotter. So how does your body actually raise its temperature? It uses two mechanisms, and both of them feel terrible. First, shivering. Your muscles start contracting and releasing rapidly, not to move you anywhere, but purely to generate heat through friction. It's the same principle as rubbing your hands together, applied to every muscle in your body at once. Second, vasoconstriction. The blood vessels near your skin narrow, pulling warm blood away from the surface and keeping it deep inside your core. This is why you feel cold and clammy on the outside while burning up on the inside. You're not confused. You're conserving heat in exactly the right place. Your body's running a furnace, and it built the furnace deliberately. Now here's what the fever is actually doing. Most bacteria and viruses evolved to thrive at exactly 37 degrees, your normal body temperature. It's the environment they've been competing against for hundreds of millions of years. But raise the temperature by 2 or 3 degrees, and their world changes. Look at this. At 39 degrees, many bacterial enzymes begin to lose efficiency. Viral replication slows. Proteins that pathogens need to reproduce start to degrade. They were built for one temperature, and that temperature is no longer what they're experiencing. Meanwhile, your immune cells, white blood cells, macrophages, neutrophils, were designed to work at higher temperatures. Their enzyme activity accelerates. They move faster, detect threats faster, and destroy them faster. Notice how the immune system doesn't just tolerate the heat, it performs better in it. And there's more. Your body simultaneously cuts off the iron supply. Most pathogens need iron to replicate. During a fever, your liver and spleen actively pull iron out of circulation and lock it away. The pathogens are starving in a too hot environment with their own biology working against them. Here's the key point. The fever is not a side effect of being sick. It is a coordinated biological weapon, and the pathogens know it. Some bacteria have even evolved countermeasures, proteins that help them survive mild heat stress. Your immune system and the pathogens inside you are engaged in an arms race that has been running for longer than complex life has existed on this planet. The fever is your oldest move in that game. The other symptoms that come with a fever aren't random either. The deep fatigue you feel is your body reallocating energy. Running a fever costs calories. Raising your core temperature by 1 degree requires significant metabolic output. Your body pulls resources away from movement, digestion, and everything non-essential, and directs them toward the immune response. The exhaustion is not the illness winning, it's the strategy. The loss of appetite follows the same logic. Pathogens need nutrients. Your body temporarily suppresses hunger, partly to limit the fuel available to invaders, and partly because digestion competes with immune activity for energy. The old saying, feed a cold, starve a fever, misunderstands the mechanism. But the instinct your body gives you is there for a reason. And when the battle begins turning in your favor, the hypothalamus resets its set point back to normal. Now your body is suddenly too hot relative to the new target. So it does the opposite of what it did before. Blood vessels dilate, sweat glands activate, heat escapes through your skin. The sweat that soaks your sheets at the end of a fever isn't a bad sign. It is the all-clear signal. So what happens when you take ibuprofen or paracetamol? These drugs block an enzyme called COX, part of the pathway that produces prostaglandins, the chemical messengers that tell the hypothalamus to raise its set point. Block the messenger and the thermostat goes back to normal. The fever drops. You feel better. Look at this. The pathogens are still there. The temperature advantage your immune system had is gone. Some research in animal models shows that suppressing fever can extend the duration of infection. The human data is more complex. It varies by illness, by pathogen, by individual. And in some situations, reducing fever is clearly the right call. But the discomfort of a fever is not accidental. Here's the key point. Feeling better after medication is not the same as recovering faster. The drug silenced the signal. It didn't change what the signal was responding to. The body is not reckless with this. There are built-in limits. Because a fever that goes too high stops being useful and starts being dangerous. Look at this scale. Below 38 degrees Celsius, you barely have a fever, more of a low-grade immune response. Between 38 and 40, that's the controlled weapon zone. The immune system is operating at full capacity. Pathogens are under pressure, and the hypothalamus is managing the temperature carefully within a functional range. Above 40 degrees, the calculation changes. At extreme temperatures, human proteins begin to denature, including the proteins your own cells depend on to function. In children, very high fevers can trigger febrile seizures. The brain, which operates within tight biochemical tolerances, becomes vulnerable. Put simply, the thermostat has a safety range, and crossing 40 degrees means the mechanism that was built to protect you has become a threat to the system it was defending. That is when medical intervention isn't suppressing the weapon. It's protecting the soldier wielding it. This video is for informational purposes only and is not a substitute for professional medical advice. Always consult a qualified doctor for your own health decisions. A fever is uncomfortable. It's exhausting. It's also one of the oldest defense mechanisms in vertebrate biology, shared across hundreds of millions of years of evolution. Every warm-blooded animal on Earth runs a fever when infected. Fish behaviorally thermoregulate by swimming to warmer water. Reptiles bask in sunlight when infected. Mammals, including you, do it biochemically from the inside. This response did not appear last century. It predates your species by an enormous margin, which raises something worth sitting with. If the fever is the weapon, if the heat is what your immune system built and deployed and is actively maintaining, then, when you reach for the ibuprofen at the first sign of discomfort, who exactly is fighting the illness? Your body has been running this response since before it was human. It doesn't need your permission. It rarely needs your help. What it might sometimes need is for you to get out of the way. And is that the same as who gets the credit when you recover?